In this video, let us try to solve a few problems from time, distance, and speed related concepts for competitive exams. The first question is, a man travels from point A to point B of distance 345 kilometers in car in 185 minutes, and returns back in bike in 3 hours 30 minutes. Which of the following is true? Speed of car is greater than speed of bike, or speed of bike is greater than speed of car, or both traveled at same speed, or this cannot be determined. Distance covered is 345 kilometers. In one way, car takes 185 minutes. While returning back, bike takes 3 hours 30 minutes. Always, convert the different units of measure to one type which you find easier to calculate. I am converting the hours values to minutes, because it's easier to calculate and compare. 1 hour equals 60 minutes, 3 hour equals 180 minutes plus 30 minutes equals 210 minutes. Car covered the distance in 185 minutes, and bike covered the same distance in 210 minutes. We know, when the distance is constant, lesser the time has greater speed. So, car is faster than the bike. Let's move on to another problem. To reach school 20 minutes early, Priya has to increase her speed to 1.5 times her usual speed. How much time she takes every day to reach the school? We know, speed equals distance by time. Always equate the value with the constant parameter. Here, distance remains constant. So, distance equals speed times time. Let's consider her usual speed and time as S1 and T1 respectively. She has to reach the school 20 minutes early from her usual time. So time is T1 minus 20 minutes. To reach 20 minutes early, she increased her speed 1.5 times. Which means speed S2 equals 1.5 times S1 equals 3 by 2 times S1. Equating with distance. S1 T1 equals S2 T2. Substituting the values, we get S1 T1 equals 3 by 2 S1 into T1 minus 20. Solving the above equation, we get T1 equals 60 minutes equals 1 hour. Priya usually takes 1 hour to reach her school. Let's move on to next problem. In this, we will see how to find average speed and how to use it to solve problems. At 10 a.m., a man travels from his home to a shop at the rate of 20 km per hour. Immediately after reaching the shop, he returns back, by traveling at the rate of 30 km per hour and reached home at 1 p.m. Find the distance between his home and the shop. Man traveled from his home to shop at 20 km per hour. We know when he has started, but we don't know when he has reached the shop. So, we do not have enough data to find distance. But, we know the time he reached home back from the shop and speed of the return journey, which is 30 km per hour. Let's consider the distance between home and shop as d. From home to shop, he traveled at the rate of 20 km per hour. Let's take this as S1. Time taken to reach shop as T1. From shop to home, he traveled at the rate of 30 km per hour. Let's take this as S2 and time taken to travel as T2. He started at 10 a.m. and reached the house at 1 p.m., which means, time taken for the entire journey, that is, from home to shop and back to home is 3 hours. Total distance covered equals d plus d. Because, distance from home to shop is equal to the distance from shop to home. So total distance is 2d. And total time is T1 plus T2, equals to 3 hours. Now we have total distance traveled, and total time taken for entire journey. We do not have sufficient data to find the distance directly. If we find the average speed, we can easily find the total distance, as we have total time. Let's calculate average speed. Time taken to travel from home to shop is, T1 equals D by S1. Similarly, time taken to travel from shop to home is, T2 equals D by S2. Average speed equals total distance by total time. So 2D by T1 plus T2. Solving, and substituting the equation, we get average speed as 2 into S1 into S2, divided by S1 plus S2. So, average speed equals 2 into 20 into 30 divided by 50. This equals to 24. Total distance equals average speed into time. So, 2D equals 24 into 3. Total distance, 2D is 72 km. Distance from home to shop is half the total distance. D equals 36 km. When a journey is split into two equal halves of distance, average speed equals 2 into S1 into S2 divided by S1 plus S2. Or, 2 divided by 1 by S1 plus 1 by S2. You can say that this follows harmonic mean. So, for n different speeds with same distance covered, average speed equals n divided by, sum of, 1 by S1, 1 by S2, up to 1/Sn. Now we will see how to solve problems with break during the journey. Two cars red and blue started from same point simultaneously, and traveled towards the same destination. The red car reached the destination first, with an average speed of 54 km per hour. And, blue car reached later with average speed of 45 km per hour. The blue car would have reached the destination, at the same time as the red car, if it would not have taken few minutes break, every hour. How much time did the blue car took break every hour? Let's understand the problem statement clearly. Red car reached the destination first, and blue car reached the destination after sometimes. Also, both car would have reached the destination at the same time, if the blue car have not taken any breaks. Actual speed of both the cars red and blue is same. But blue car took break every hour. So, let's consider the actual speed as the speed of red car, which is 54 km per hour. We know, for a constant distance, if time taken to reach increases, the speed of the object decreases. Here, due to stoppages, blue car's time to reach destination has increased. Hence, its average speed got reduced. Average speed of the red car is 54 km per hour, blue car is 45 km per hour. Which means, red car traveled 54 km in 1 hour. And, blue car traveled 45 km in 1 hour. In 1 hour, if the blue car did not stop, it would have covered 54 km. It lost 9 km in 1 hour. If we know the time taken to cover 9 km considering actual speed, then we can find how much time the blue car stopped per hour during the journey. Time is equal to distance by speed. Time taken to cover 9 km is equal to 9 km by 54 km per hour, which is 1 by 6 hour. Converting this to minutes, we get 10 minutes. So, blue car took 10 minutes of break every 1 hour. To conclude, in a journey with stoppages, the average speed is always lesser than the actual speed of travel. Time taken for stoppages per hour equals distance lost due to stoppage in 1 hour, divided by the actual speed of the object. Two cars, red and blue, start simultaneously and are traveling in opposite direction from point A and point B. They arrive at the destination, in 16 hours and 9 hours respectively, after crossing each other. At what rate does the blue car travel, if speed of the red car is 60 km per hour? Let's consider the speed of the red car as SR. This is equal to 60 km per hour. And speed of the blue car as SB. Red car starts at point A, and blue car starts at point B. Both the cars meet at point C at the same time. This means time taken by both the cars to reach point C is same. Time taken to cover distance between A and C by red car is equal to the time taken by blue car to cover distance from B to C. Let's consider this as T. After crossing each other at point C, red car takes 16 hours to reach point B. Let this as TR. Blue car takes 9 hours to reach point A. And this is TB. We know, distance equals speed into time. So, distance covered by red car, from A to C equals speed of the red car, into time taken by red car to reach C. Distance AC equals SR into T. Distance covered from C to B equals speed of red car, into time taken to reach point B from C. Distance CB equals SR into TR. Similarly, for blue car, distance covered from B to C equals SB into T. And distance covered from C to A equals SB into TB. For solving the problem, let's take a ratio of the distance traveled by both the cars, before and after reaching point C. Distance from A to C, by distance from B to C equals AC by BC, equals SR into T, by SB into T. Which is equal to SR by SB. Similarly, distance from C to A, by distance from C to B equals CA by CB, equals SB into TB by SR into TR, as distance from A to C equals distance from C to A, and distance from B to C equals distance from C to B. We will equate the ratios to find the speed of the cars. AC by BC equals CA by CB. This means SR by SB equals SB into TB, by SR into TR. Solving this, we get SR by SB equals square root of TB by TR. Substituting the values, we get SR by SB equals square root of 9 by 16, equals to 3 by 4. So, SB equals 4 into SR by 3. We know, speed of the red car is 60 km per hour. Therefore, SB equals 4 into 60 by 3 equals 80 km per hour. Speed of the red car is 60 km per hour and speed of the blue car is 80 km per hour. So, speed of the blue car is 20 km per hour more than the red car. With this, we arrive at the formula. With distance as constant, when two objects cross each other, speed of object 1 by speed of object 2, equals square root of time taken by object 2 by time taken by object 1, after crossing each other. Let's solve one of the famous problem in competitive exams. Two trains start from station A and B, which are 400 kilometers apart. First train starts at 9 a.m. and travels towards B at the rate of 50 km per hour. Second train starts from B at 10 a.m. and travels towards A at the rate of 40 km per hour. At what time do they cross each other? Let's visualize the problem. Distance between point A and B is 400 kilometers. Train 1 starts at 9 a.m. and travels at a speed of 50 km per hour. Let this be S1. Train 2 starts at 10 a.m. and travels at a speed of 40 km per hour. Let this be S2. Both the trains meet at point C. Let's assume the trains meet at point C, t hours after 9 a.m. So, distance traveled by train 1, from A to C, equals, speed of train 1, into, time taken to reach C. So, d1 equals s1 into t. Train 2 starts at 10 a.m. This is 1 hour later than 9 a.m. So, time taken to reach point C is, t minus 1 hours. Distance traveled by train 2, equals, speed of train 2, into time taken to reach C from B. So, d2 equals s2 into, t minus 1. Considering both the journeys of train 1 and train 2, total distance from A to B, equals, distance traveled by train 1, from to A to C, plus, distance traveled by train 2, from B to C. Total distance equals, s1 into t, plus, s2 into, t minus 1. Substituting the values of speed. Total distance equals, 50 into t, plus 40 into t minus 1. This is equal to 400 kilometers. Solving this equation, we get t equals 4 hours. So, trains meet 4 hours after 9 a.m. Which means, both the trains meet at 1 p.m. Some of the common problems in competitive exams include, train crossing a pole or a station. Let's see few assumptions to be considered, while solving these problems. When a train of length L, crosses a static object like pole, distance traveled, equals length of the train, equals L. When a train of length L, crosses a station of, x meters long, distance traveled, equals, length of train, plus, length of station, equals, L plus x. Thanks for watching our video.